Humming along like the efficient machine that it is, the human body is largely dedicated to taking in and using energy. Three interlocking systems, digestion, circulation, and respiration, work ceaselessly to accomplish this. They pull in food, supply oxygen to help burn that food at the cellular level, and circulate the oxygen and nutrients throughout the body. Your basic metabolism, your physical activity, and the energy required to process food use about 1,600 to 2,000 calories a day. Meanwhile, the body continually filters out and expels wastes such as indigestible foods, toxins, and carbon dioxide. Protecting the entire organism while all this is happening is a job for the immune system, which is a complex and powerful system. The immune system's workings are still only partially understood. We do know that they begin with physical barriers such as the skin, move on to immediate responses by blood cells on the defense, and add specialized responses in which the body learns to recognize invaders and target them for destruction the next time around. Are you interested about that? Of course you are, because today's episode from our Essential Guide to Your Body and Brain is about the care and feeding of the body. This is your host, Danny, and this is a new episode from English Plus Podcast. Now, before we start our episode for today, I would like to remind you that you can find the transcript for this episode on my website, EnglishPlusPodcast.com. And while you're on the website, take the time to explore the website and see the many learning opportunities that are both educational and entertaining. There are audio series, video series, the daily English bites, the many other episodes and series that are running along in English Plus Podcast itself, and there are also the online courses and the English Plus books that you can find on the website. Sample them before you decide to buy them. And now, without further ado, let's start talking about the care and feeding of the body in a new exciting episode from our series, An Essential Guide to Your Body and Brain. That's coming next. Don't go anywhere. I'll be right back. Now we will start our journey in today's episode by talking about the circulatory system, the pulse of life. The circulatory system, which is the body's all-purpose workforce, has three basic jobs: transportation, protection, and cooling. Blood carries oxygen, nutrients, and hormones to tissues and totes away carbon dioxide and other waste products. It also contains immune system cells that fight off viruses, bacteria, and other invaders. Platelets and clotting agents in the bloodstream speed to the sites of injuries and seal them off in minutes. And blood disperses heat around the body, and by doing that, it helps cool the brain and other hard-working organs. Well, as you're listening to me, all of that is working, and it never stops. But it all starts at the heart. The heart is the central engine of circulation. It's just a fist size, roughly cone-shaped lump of muscle, and it nestles between the lungs in the middle to the left part of the chest. Connected to the heart is a closed network of blood vessels. Well, actually two networks. The left side of the heart pumps blood to all parts of the body except the lungs, while the right side supplies the lungs only. The largest blood vessels are the arteries. They're big, elastic tubes that carry blood away from the heart. Arteries branch out into smaller channels called arterioles, which lead into a fine webbing of tiny blood vessels called capillaries, where oxygen and nutrients are exchanged with the tissues. Their job accomplished, capillaries merge into tiny veins called venules, which connect to larger veins that carry blood back to the heart. Such a complicated thing happening without even us thinking about it. And that's the beauty of it. Imagine if you had to think about that and if you had to decide what to do. I mean, we would be all dead in seconds, if not even faster. But our great bodies do all that on their own. But don't think that's the end of it. We're gonna talk about blood cells next, because this miracle is not over yet. Next, we're gonna focus on the blood cells, so don't go anywhere. I'll be right back. Although it is a fluid, blood is also a connective tissue whose individual cells float suspended in liquid plasma. The straw-colored plasma is made mostly of water but has some nutrients like hormones, gases, and other substances dissolved in it. This fluid makes up almost 55% of the bloodstream. Carried in it are the so-called formed elements of blood, the red blood cells, and an assortment of white blood cells and platelets, constituting less than 1% of total cells, but they're essential for life nonetheless. So let's talk about the red blood cells. Red blood cells have only one job, and that is to carry respiratory gases to and from the body's tissues. Hemoglobin molecules within the cells contain a red pigment that gives blood its color. And contrary to popular belief, although human blood changes color as it circulates, it is always red. Veins look blue because the overlying tissues filter out red light at that depth. So don't worry, nobody's blood is blue. Red blood cells are red all the time. Well, it changes color a little bit, but it's always red. But anyway, let's continue talking about those blood cells, those red blood cells. Those blood cells don't live for long, so they must be replaced constantly. Most are produced in the bone marrow, which is a spongy connective tissue within the bones. Now, lacking a nucleus and most other organelles, red blood cells last only about 120 days before dying at a rate of about 2 million per second. But don't worry, new red blood cells, fresh blood cells, are being produced in your body all the time. And here, let me tell you about cutting-edge technology that has to do with treating cancer, and that is called targeted medicine. Now, attacking cancer through traditional methods such as chemotherapy and radiation is like carpet bombing the whole body. The treatments damage the target, all right, but they harm healthy areas as well. In recent years, however, scientists have developed medicines that operate more like bullets, taking out the enemy without hurting civilians. Targeted therapy is coming into its own thanks to breakthrough in understanding the genes that spark cancers and the molecular pathways that guide cell growth. The new medicines typically work by interfering with the processes of a tumor's growth. For instance, the drug imatinib mesylate, marketed as Gleevec, blocks the signals of an abnormal growth-inducing protein found on the surface of cancer cells. In patients with chronic myeloid leukemia, which is a cancer of the white blood cells, survival rates with Gleevec now stand at about 70%, up from about 15% in the 1980s. I know that didn't really have to do with the blood cells, but I just couldn't miss this opportunity to tell you about some cutting-edge technology that is being used to cure cancer. And hopefully they will move from carpet bombing to dispersing soldiers who use bullets to kill the enemy to using snipers, where they can just kill the target and no one else. And hopefully they will get to that in the years to come, but more importantly, we hope that they make this available to everyone, not just to the elite few that can afford it. But anyway, we're talking about the body. Let's not get into politics. And next, we're going to talk about the most important muscle in our body. That's coming next. Don't go anywhere. I'll be right back. Press 2 fingers firmly between the 5th and 6th ribs from the top of your left side. The steady thump you feel is your heart beating. The organ itself is a muscular little 4-chambered machine, which is only the size of a large fist. It is hollow and light, weighing about 8 ounces or 227 grams in adult women and 10 ounces or 283 grams in adult men. It can be thought of as 2 side-by-side pumps. The left side collects oxygen-rich blood from the lungs and pumps it to the rest of the body, while the right side collects oxygen-poor blood from the body and pumps it to the lungs for oxygenation. And it's not just a big muscle on its own. There are chambers, there are walls inside your heart. The chambers consist of 2 atria on top, and atria is the plural word for atrium, which means an entry hall. So we have 2 atria on top and 2 ventricles below, and the ventricle means the little belly. So we got 2 entry holes on top and we got 2 little bellies at the bottom. The atria are separated by a thin wall called the interatrial septum. The atria are the collecting rooms for returning blood. With each beat, they pump this blood through valves into the larger and more muscular ventricles, which pump it out of the heart. The ventricles, too, are separated by a partition, the interventricular septum. Now, this fact is indeed mind-blowing. Contracting and relaxing, imagine, a whooping 100,000 times a day. That's about 35 million times a year and almost 3 billion times in the average lifetime. That's what your hearts do, ladies and gentlemen. The heart tirelessly pumps blood throughout the body and keeps every cell oxygenated, fed, protected, and functioning. So knowing that you have a machine like this, please take care of it because it is definitely the most important muscle in your body. So that was about the most important muscle in your body, and next we're going to talk about the cardiac cycle. So don't go anywhere. I'll be right back. The heart's electric signal begins in the sinoatrial node, or the SA node, the heart's natural pacemaker, which is located near the top of the right atrium. This tiny piece of tissue is made of autorhythmic fibers, specialized heart cells that take in and expel calcium and other electrolytes to regularly change their electric charge. The electrical impulse produced by the cells of the SA node spreads through the walls of the atria by moving from one cardiac cell to the next via gap junctions, passageways that connect two cells. The signal makes the muscle cells of the atria contract in a sequenced fashion, and this action presses blood into the ventricles. So what is one heartbeat? Flowing continuously through a healthy heart, blood moves from regions of higher pressure to regions of lower pressure. Oxygen-poor blood enters the right atrium, is pumped into the right ventricle, and is pumped again through the pulmonary artery to the lung to pick up oxygen. It returns via the pulmonary vein to the left atrium, enters the left ventricle on the next contraction, and exits to the body through the aorta. The whole sequence associated with one heartbeat is called the cardiac cycle. Typically lasts about 0.8 seconds and pumps about 2 ounces or 70 milliliters of blood out of each ventricle. That is just one heartbeat, ladies and gentlemen. And that is, again, one of the miracles that happen within your body every single second, more or less, of course. And here, because we've talked about how important this muscle is, and all these things we've been talking about so far, and a lot of other things that are coming in this episode are just miraculous. But that doesn't mean that nothing can go wrong. Well, we all know that things can go wrong in this miraculous little muscle. So the best advice doctors give in these situations is don't die of embarrassment. Well, what does that mean? Let me tell you. Some heart attacks strike silently, leaving victims, if they survive, of course, unaware that they even occurred. More often, there is some kind of chest discomfort. The symptoms can simulate bad indigestion, a tight band around the chest, or pressure so intense that it feels like an elephant is sitting on the chest. Pain can radiate into the arms, shoulders, jaw, or torso. Other symptoms include nausea, shortness of breath, profuse sweating, and dizziness. The stereotypical scene in which someone clutches his chest, drops to the floor, and dies is pretty much unusual. But because many people associate similarly dramatic symptoms with a heart attack, they wait too long to call for emergency assistance. And time, as doctors say, is muscle. In fact, almost half of all deaths from heart attack happen outside a hospital. In too many cases, denial and embarrassment prevent people from calling for help. Even among people who recognize their symptoms, only 50% call an ambulance, and the rest drive themselves or are driven to the ER. Doctors say, don't let your fear of looking foolish stop you from calling 911 or any other emergency number relevant to your country. And remember what doctors say, don't die of embarrassment. Well, there's obviously nothing embarrassing about that, but even if it is, even if you believe that it is embarrassing, it's a lot better to be embarrassed than dead. Believe me. All right, you might think that we're done with the circulatory system, but we're not. We're going to talk about blood vessels next, so don't go anywhere. I'll be right back. Within its closed loop, the circulatory system encompasses thousands of miles of blood vessels reaching virtually every cell in the body. 3 types of blood vessels, which are the arteries, veins, and capillaries, make up this intricate road map. Arteries carry blood away from the heart. Capillaries, the tiniest pathways, carry it into the tissues, and veins take it back to the heart. The big, elastic arteries that exit the heart join medium-sized arteries whose thick, muscular walls ferry blood to organs and limbs. Flowing into smaller and smaller arteries, blood reaches the arterioles, which are tiny vessels with thin walls, before entering the capillaries. Now, as small as they are, the microscopic capillaries are arguably the most important parts of the circulatory system, for they are the vessels that do the work for which the system was built in the first place. Known as exchange vessels, the capillaries transport nutrients, wastes, gases, chemicals, and even heat between the blood and the interstitial fluid that fills the spaces between the cells of tissues. After releasing their load and picking up wastes and other cargo from the tissues, capillaries merge to form small veins called venules, which drain into large veins that carry the deoxygenated blood back to the heart. The whole system is briskly efficient. It takes about 1 minute for each blood cell to make a circuit of the body. And now, I know that most of you were kind of afraid when I talked about heart attacks, so let's talk about something a little bit more positive, and let's talk about keeping healthy. And how do we do that? Keep it moving. Bedridden patients and some airplane passengers may share an unfortunate side effect of immobility that is called deep vein thrombosis. The condition is caused by blood flowing slowly or pooling in the deep veins in the lower legs or thighs of an unmoving person. If the blood is unable to wash away clotting factors, a blood clot or a thrombus can form, blocking circulation. The limb becomes tender, swollen, hot, and red. The clot can break away and travel to the brain, where it can cause a stroke, or to the lungs, heart, or other areas. Doctors may prescribe anticoagulants to the bedridden, and people prone to the condition can wear compression stockings to prevent pooling. Plane or car passengers on a long trip should take periodic breaks to stand up and get that blood moving. And for all of us, which we have a big problem that we're sitting in our chairs for very long times, I'm guilty of that. Because I do what I do, I have to sit for very long times. But I keep reminding myself every 30 minutes, 45 minutes, or maximum an hour to just get up and move. Do something, and don't forget that physical exercise, regular physical exercise, helps a lot to keep your blood moving in a healthy way all around your body to prevent clotting and prevent bigger problems. Well, they say sitting is the new smoking, and they're not that wrong about it. So just consider it for people who sit for long periods and they don't move a lot. Just consider taking short breaks just to move around. Just take a short walk for like about 10 minutes or so. Don't keep sitting down. Keep it moving and stay healthy. So what's coming next in our episode? We're going to talk about the vital exchange. And that's coming next. Don't go anywhere. I'll be right back. Immersed in a bath of air, the body takes in oxygen with every breath. Each of its trillions of cells depends on this infusion for survival. Without oxygen, brain cells begin to die within 5 minutes, and other tissues expire within hours. In biological terms, respiration involves much more than the act of breathing. It encompasses the whole process by which oxygen is delivered to the cells and used to break down glucose from food, and by doing that, it releases energy. Respiration also removes its own toxic waste product, which is the carbon dioxide, with each exhalation. Other respiratory tasks include moving air across the vocal cords for speech and pulling smells into the nose. So what about the respiratory zones? The respiratory system can be divided into two zones, conducting and respiratory. The conducting portion includes all the tubes and channels that carry gases in and out of the body. It begins with the nose and mouth and leads down the pharynx or the throat, past the larynx, which is the voice box, and into the trachea, which is the windpipe. This passageway branches like an upside-down tree into the lungs, where it spreads into smaller and smaller airways, the bronchi and the bronchioles. The respiratory zone is made up of the tissues in the lungs where gas exchange occurs. It consists of the smallest bronchioles and the alveoli, delicate air cavities that are attached to the alveoli like clusters of grapes. Capillaries that cover the alveolar sacs pick up oxygen and deliver carbon dioxide through the porous alveolar walls. And this exchange is quite vital for survival because every single cell of the trillions of cells in your body need this. So let's talk next about the breathing machines you have in your body. That's coming next. Don't go anywhere. I'll be right back. The lungs are the central organs of respiration. They are so light that they float in water. In fact, the word lung comes from an early Germanic word meaning light. In older English usage, lights is a synonym for lungs, as in the recipe for liver and lights. The well-known lightness of the lungs reflects what is perhaps their key characteristic. They are filled with millions of air pouches, or alveoli, that provide an immense amount of surface area for moving gases both in and out of the bloodstream. These two cone-shaped, spongy organs occupy most of the chest cavity within the ribs. Slightly asymmetrical, the left lung is about 10% smaller than the right because it contains the cardiac notch that curves around the heart. The right lung, however, is shorter than the left because the liver presses the diaphragm up under its base. The lungs are divided into sections, or lobes, 3 in the right lung and 2 in the left. Each lobe is supplied with air by its own bronchus, and each has its own artery and vein. The lobes are subdivided into segments and then further divided into lobules, about 130,000 in each lung. These polyhedral structures give lungs their slightly lumpy tiled appearance. Both lungs are covered by a fluid-filled double membrane called the pleura. Beneath the lungs, the dome-shaped diaphragm muscle contracts and relaxes to expand and relax the lungs in the act of breathing. So these are our breathing machines. And we're not arguing here whether they are more important than the heart or whether the heart is more important than them. They're all very important, and they all need to be well taken care of. And next, we're going to talk about fueling and filtering. That's coming next. Don't go anywhere. I'll be right back. Converting your breakfast into fuel for your morning swim is the job of your body's digestive system. The journey takes place in the gastrointestinal, the GI tract, or alimentary canal, which is a 30-foot long or 9.1 meter long tube that begins at the lips where food is mashed, mixed with chemicals, and mashed some more as the body extracts every last bit of nutrition from it. The teeth begin the breakdown process by tearing and grinding the food. Salivary glands secrete saliva and mucus to moisten it into a soft paste. Muscular reflexes push the food down the esophagus toward the stomach. Acidic gastric juices turn it into a soupy mixture, which is then churned until it passes into the small intestine. Quite a journey for every single bite you eat. So then what about digestion? Most digestion occurs within the 10-foot long or 3-meter long small intestine, aided by the liver, pancreas, and glands within the bowl itself. Millions of tiny projections called villi increase the surface area of the small intestine some 8 times to about 2,000 square feet, or 186 square meters. Nutrients pass through pores in the villi into the capillaries and thus into the bloodstream. Like a widening river, the small intestine joins the large intestine or colon. The large intestine's main function is to move waste slowly but steadily out of the body. Let me take this opportunity and talk about another cutting-edge thing when it comes to your guts, and we'll call that gut instincts. Scientists recently began to appreciate the fact that your body is a walking microbiome. 100 trillion bacteria live in and on your person, mostly in your gut. And almost all of them are either helpful or at least neutral in their effects. Scientists now believe that these microbes may have a far bigger impact on health than previously thought. They affect everything from immunity to mental health. One of the most intriguing areas of medical research focuses on the link between gut bacteria and obesity. In one study, researchers transferred gut bacteria from identical human twins, one fat, one thin, into mice. Mice who received the fat twins' bacteria gained weight. Mice who received the thin twins' microbes stayed lean. Moreover, the fattened mice lost weight again when they received a thin mouse's bacteria. It seems that in the battle of the microbes, the lean team always wins. But of course, there's still a lot of research going on in this area, but who knows? If we can really crack the code of these microbes that already live within our guts, we might be able to solve a lot of problems. Obesity is just one of them. So, we're still talking about food, and we're not done. We're going to talk about digestive organs next. So don't go anywhere. I'll be right back. Aiding the small intestine in its task of digestion is a team consisting primarily of 3 organs: the liver, the pancreas, and the gallbladder. The versatile liver is the body's largest gland. Weighing in at 3 pounds or 1.3 kilograms, it's mostly tucked in the right rib cage, just below the nipple. Among its many jobs are synthesizing proteins for blood plasma, filtering toxins from the blood, storing glycogen and iron, destroying old blood cells, and producing vitamin D. It also makes bile, which breaks down fats during digestion. And that's why we called it the versatile liver. And needless to say, that's also one more organ you need to care for in your body. And to be honest, maybe that's the point of this whole series, an essential guide to your body and brain. When you really understand what's happening inside your body and brain, you get to appreciate the complexity, the delicacy of what's happening inside, and you might want to protect these organs a lot more than before. Maybe we all take our bodies for granted. And it's okay, our bodies are strong, but we need to keep them as strong as possible for as long as possible. But anyway, we talked about the liver. Let's talk about the other digestive organs. And next is the gallbladder. The gallbladder is a plum-sized green muscular sac hanging from a depression in the back of the liver and peeking out below the liver's right lobe. Its job is to store and concentrate bile from the liver. And there's also the pancreas. The pancreas is about 5 to 6 inches or 12 to 15 centimeters long and consists of a body, a tail that abuts the spleen, and a head that nestles into the curve of the small intestine. The pancreas is a complex organ, and the word itself comes from all plus flesh. The pancreas produces digestive enzymes and secretes them into the small intestine. There, the enzymes break down starches, proteins, and fats. The pancreas also does double duty as an endocrine gland, releasing hormones such as insulin and glucagon to control blood sugar. So these were 3 digestive organs that do kind of different jobs, but they all work together as one to help you use up as much nutrients as possible from the things you eat. And next, we're going to talk about cleaning up. That's coming next. Don't go anywhere. I'll be right back. The heart, the lungs, and the gut may get the most attention for fueling the body. But without the constant cleansing of the urinary tract, we would quickly die a poisoned, bloated death. Anchored by the multitasking kidneys, each one the size of a pack of cards, the urinary system processes the body's entire blood plasma more than 60 times a day. After purification, most of the watery fluid pulled from the blood plasma is returned to the bloodstream. The rest, less than 1%, is sent to the bladder for storage and excreted as urine. Through urine, the kidneys rid the bodies not only of metabolic waste such as ammonia and urea, but also of foreign toxins like drugs and environmental poisons. While the kidneys are making urine, they are also cleansing the blood by fine-tuning its chemistry and volume. By regulating the blood's pH level, kidneys keep the bloodstream and other fluids in top condition. The amount of salt and water that the kidneys filter, reabsorb, and excrete from the blood controls the blood's volume and hence its pressure. The kidneys also regulate the osmotic pressure or relative concentration of the blood compared with outside fluids, as well as the composition of all fluids in the body. By maintaining electrolyte and water homeostasis or equilibrium within narrow limits, the kidneys make it possible for human bodies to function on dry land. It's just marvelous, isn't it? Every single organ we talked about so far. Can you imagine that all of this is happening right now as you are listening to this episode? And it has been happening since you were born or even a little before. All of these things happen and keep happening until one thing goes wrong. And while things can go wrong, and you might not be the direct cause of these diseases or problems, at least you know that you can help your body stay as healthy as possible by taking up some good habits. And I hope this little knowledge I am providing in this series, an essential guide to your body and brain, will help you appreciate this complex factory that you have within your body. Now, we have one more thing to talk about in today's episode of our Essential Guide to Your Body and Brain series, and that has to do with protection and immunity. That's coming next. Don't go anywhere. I'll be right back. Every day, a host of potential invaders attacks the body. These microorganisms, called pathogens, come in the form of viruses, bacteria, parasites, and fungi. The immune system sets up a multi-tiered defense. Not confined to a particular set of organs, the immune system operates throughout the body. Its work carried out by the body's trillions of immune cells and specialized molecules. The first line of defense lies in the physical barriers of the skin and mucous membranes which block and trap invaders. A second line of defense, the innate system, is composed of cells including phagocytes whose basic job is to eat the invaders. In addition to these immune cells, many chemical compounds respond to infection and injury, move in to destroy pathogens, and begin repairing tissue. The body's third line of defense, the adaptive defense system, is a final, more specific response. Its elite fighting units are trained on the job. That is, they are created in response to a pathogen that the body has not seen before. Once activated in one part of the body, the adaptive system functions throughout the body and it memorizes the antigens, which is a substance that provokes an immune system response so that the next time they come along, the body hits back quicker and harder, which is better than any security system and any army out there. No matter how advanced your weaponry is, your body got it better. But talking about that, what can go wrong? And here we'll talk about allergies. In some people, the immune system can be too sensitive. Pollen, animal dander, or foods that are not intrinsically harmful, such as peanuts, are interpreted by some immune systems as dangerous antigens. The result is an allergic reaction, which might include sneezing, tissue inflammation, and mucus secretion. In the most serious cases of anaphylactic reactions, airways can constrict while blood vessels dilate, leading to shock and even death. For reasons not clearly understood, allergies are on the rise worldwide. One theory blames hygiene, suggesting the growing body needs to be exposed to a variety of germs and other environmental items such as pollen in order to develop a mature immune system. Allergies may be the price we pay for a clean, antibiotic-filled world. So of course, we're not saying we should go back to being dirty and that we shouldn't care about our hygiene, but too much of one thing is simply too much. And that especially applies to parents when they try to protect their children a little bit too much from the environment. I mean, a little exposure to the environment is actually healthy in the long run. And it might, I'm not saying that it will, it might prevent some allergies from developing in your child in the future. Who knows? Anyway, that was about allergies. Next, we're going to talk about the killer cells. That's coming next. Don't go anywhere. I'll be right back. The body's internal defenses rely heavily on two kinds of aggressive cells: phagocytes and natural killer cells, or NK cells. The main phagocytes are macrophages, and these literally big eaters wandering macrophages move about in search of infections and feast on microbes and debris. Fixed macrophages live in such organs as the liver and the brain. After macrophages, the most important kind of phagocytes are neutrophils, which are the most abundant type of white blood cell. Another kind of white blood cell, the eosinophil, is not a heavy eater as phagocytes go, but it is important in killing worms and other parasitic invaders. And here we come to the natural-born killers. The other family of cells, the NK cells or the natural killer cells, compose of some 5 to 15% of all lymphocytes. Like the phagocytes, they reside in the spleen, the lymph nodes, and the red bone marrow. These helpful assassins can terminate a number of infectious microbes and cancer cells by zeroing in on cells that have inadequate plasma membrane proteins. Natural killers shoot their targets full of holes, attacking the membrane of a target microbe with chemicals called perforins, which make the microbe leak to death. I mean, that's kind of scary. They can also kill by releasing into target cells molecules that lead to apoptosis, or programmed cell death. I mean, these are trained assassins. No one is better. I mean, not even 007 can pull off such assassinations. And these are natural-born killers. They are in your body. You don't do anything. You don't pay anything to create those. They come naturally with your body. But then, we talked about those killer cells and the immune system, but what can go wrong? Hijacking the immune system can go wrong. And here, we're going to talk about AIDS. And AIDS is short for Acquired Immune Deficiency Syndrome, or AIDS, AIDS. AIDS targets the body's immune system and cripples its ability to defend itself from infection. It was first reported in 1981. The disease has spread around the world. Currently, more than 34 million people worldwide have HIV/AIDS, and about 35 million have died of the virus. Human immunodeficiency virus, or HIV, the virus that causes AIDS, operates by turning the body's immune system against itself. HIV enters immune cells, sheds its protective protein coat, and hijacks the cell's engines to make a DNA copy of its own RNA, which then is incorporated into the host cell DNA, forcing a cell to make an army of viruses. Despite the insidious nature of AIDS, survival rates have increased dramatically as patients use combinations of potent drugs. And although there is no vaccine yet, a daily antiviral pill called Truvada can reduce the chance of those not yet infected of contracting the virus by 99%. It decreases the virus's ability to infect healthy cells at the time of exposure. But of course, you know the best way to fight AIDS is to protect yourself, to prevent it from even happening. You need to protect yourself during sex by using a condom. You need to protect yourself if you inject drugs. Protect others if you already have HIV. And of course, I'm not going to talk a lot about it. Maybe we should talk about it in one episode. And the most important thing is learning about the thing and enlightening others of the dangers of HIV and how we can protect ourselves against this virus. We still have one last thing to talk about that has to do with immunity, and that's what we're going to talk about next, so don't go anywhere. I'll be right back. Unlike the broad attack of the innate defense system, the adaptive immune system attacks pathogens with specific, made-to-order antibodies and cells. The antibodies and lymphocytes of the adaptive system can recognize millions of different pathogens, some not even found in nature, and they can distinguish infected, cancerous, or foreign cells in an organ from normal cells of the same type. Each antibody and lymphocyte recognizes only one kind of antigen. The receptors on the surface of each lymphocyte recognize the specific chemical structure of the antigen and fit the antigen like a key sliding into a lock. The body must be primed by an introduction to these antigens. Then the old adage applies: that which does not kill you makes you stronger. The adaptive immune system manufactures the necessary antibodies and cells so that upon re-exposure, you can fight back and win. Thus, unlike the innate system, the adaptive system is a highly specialized fighting force with a killer memory. And with that, we've talked about the feeding and caring of the body. We talked about the circulatory system, the pulmonary system, the digestive system, and finally, the immune system. Of course, there's no room in one episode or even in one series to talk in detail about all these things, but I hope, as I usually do, that I can pique your curiosity just enough for you to go look up some of the things we talked about today and dig in a little bit deeper to learn more. That's my motto in English Plus: never stop learning. But with that being said, that'll be everything for today's episode. Don't forget that you can find the transcript of this episode on my website, EnglishPlusPodcast.com. The link is in the show notes. And while you're there, just explore the site and see the other educational and entertaining learning opportunities you can find there. With that being said, I would like to thank you very much for listening to another episode from English Plus Podcast. This is your host, Danny. I will see you next time.